Como ya saben, bueno, si leyeron los programas, la conferencista que sigue es mejor conocida como la madre de Internet. Tiene registrada más de 70 patentes relacionadas con la seguridad en línea. Un fuerte aplauso para Radia Perlman, por favor.
Wow. Thank you so much. This is an overwhelming event. It is just amazing. It's the first time I've been to a campus party, and it's just fantastic in so many different ways. Anyway, so what I'll be talking about is, let's see, my slides are not showing, but they are over there.
There is a trouble with your presentation, but they are fixing the problem, so I don't know, you can start talking and then they will put the, oh, it's right here.
Okay. So I wasn't quite sure what to talk about, but I'll just kind of talk about my career and the lessons I've learned from what's happened so far. So what do? I design ways for computers to interact with each other over a network. And my two specialties are how they cooperate to figure out how to move the data around the network, and the other is security stuff. Cryptography, how you prove across a network who you really are. I also write books and give talks, and I love any opportunity to teach. So I'll tell you how I got here. If you had asked me when I was young what I wanted to be when I grew up, I certainly wouldn't have said, I think I'd like to design computer network protocols. You know, I really knew nothing about computers. And how I got to where I am is a complete set of random events. You know, how I wound up in this industry, how I wound up learning to program a computer, and I'll explain about that. And I love how it turned out. I probably would have been just as happy if I wound up in chemical engineering or something, but you know, random events are just fine. So the lesson to be learned is that you shouldn't worry about finding the one thing you were born to do. Some people have a passion at a very early age for solar power or something like that, and that's great. But most people, you know, are really, you know, very flexible, which is another good way to be, and I certainly was. So when you're making decisions, if you're agonizing over, should I go to this college or that college, should I go to graduate school or get a job, you know, what should I major in, whatever, the advice I give to people is that you will never have enough information to make an informed decision. You really don't know what it will be like at that college. It depends on what professors are there. If you have a horrible roommate, it could sour the whole thing. You'll never be able to predict the outcome of these decisions. And so what I tell people is, instead of agonizing over these decisions that you don't have enough information to make, just realize that there's two types of people in the world. Those that would be happy with either decision, and those that would be unhappy with either decision. So it's like, you know, do whatever and just make the best of it. So school before college, I loved logic problems, and I was good at all of my classes, but I did not fit the stereotype of an engineer. I never took things apart. It never occurred to me to take anything apart. I would have assumed I would break it or get electrocuted or something. And so that's kind of a dangerous stereotype of an engineer. That, and I've heard that there's a hiring manager someplace that says, what were your hobbies when you were 12? And if you don't say, I built a computer out of spare parts, he just doesn't think that you really could be a serious engineer. But you know, the most important thing is to have a team that looks at problems different ways. So even though I never wanted to dive right in and do things, I understood the logic of it, and I, you know, really could think about problems. So I knew nothing about computers before, high school. And if I knew more about computers when I was younger, if somebody had asked me, what would you like to do when you grew up, I probably would have said, I'd be happy doing pretty much anything except computers. So I pretty much hate computers. I have a smartphone only finally because my company gave it to me, and I barely know how to do anything with it. It sits on my desk making funny noises. I have no idea why. Frankly, I think this industry could use more people like me that hate computers because engineers should actually meet some humans. They obviously haven't, because if they met humans, they wouldn't have programs ask you questions like, do you want to display both the secure and the insecure items? What a crazy thing. I even know what it means, and it still is a crazy thing. And then once I was trying to install an email client, and it asked me, do you want to use POP or IMAP? That's not a question you should ever ask a human being. I happen to know that it's two different email standards, but why would I care about one or the other? Turns out it's a very important decision because you have to speak what the server speaks. How am I supposed to know what the server speaks? So, it's this sort of thing that it's better if you have some people that don't just enjoy learning a million different commands and all this kind of stuff and want to make things very usable. So the way I learned when I was in high school, a teacher noticed, one of the high school teachers noticed there was a computer programming class at a local university, and the timing worked out so that she could register a few of us in the class and she could drive us there. And she did this all as a volunteer, and teachers are just awesome. So I managed to get enrolled in this computer programming class. Now, after years of always being the top student in in all of the classes, especially math and science, which, by the way, I wasn't happy about. I always had a fantasy that some boy would do better than me at some math or science thing, and my plan was to fall in love with him and marry him. But, years of kind of just knowing, okay, here's a physics class, here's a chemistry class, and looking forward to all the interesting problems that I would learn. With great self-confidence, I walked into this computer programming class, and all of the students were talking about how they had built ham radios when they were 7 years old. And it's like, I had no idea what a ham radio was, or what you would use it for, how I would plug it in. And it was extremely intimidating. And then they were asking questions with fancy words like input. I had no idea what that meant, but it just felt like I was so far behind all the rest of the people that I would never actually catch up. So in this one class, for the first time, I got nothing out of the class. I didn't learn anything because I just made the assumption that everybody else already knew everything and I would never catch up. I didn't ask any, just a few simple questions would have cleared everything up, but I just convinced myself somehow that I was too far behind. It does make me a great teacher, this experience, because I understand the sense of panic that can prevent someone who's otherwise perfectly capable of learning from learning, because I experienced it myself. So the lesson is that much of success is self-confidence. And you can try to instill it in those around you. So for instance, it has to be safe to ask questions. So I was in a group once that the culture was dominated by these really obnoxious, very aggressive people. I've never met anyone who acted that way that was actually good technically. But they seem impressive. People just assume they must be geniuses or something. But if you asked a question, their answer was always, if you don't know that, you don't belong in this group. So, you know, what I say is if somebody asks me a simple question like, what's a public key, which everybody knows, right? I don't say, how can you not know that? I say, oh my goodness, it is the coolest thing ever, and I can't believe that I have the good luck to have the honor of being the first person to explain it to you. Also, sometimes very basic questions make you question your assumptions. Because another whole talk that I like to give to people who are very experienced in networking is, here's a bunch of things everybody knows about networking that are all wrong, and let me explain why they're wrong. Yeah, you can nurture self-confidence in those around you, and please do that. It will be a better world. I'm not quite sure what you can do about yourself. You can tell yourself, you know, not to let that stop you, but it is very hard. You know, hopefully you can find people around you that you feel safe enough to say, I just have no idea how to approach this or whatever, and they will help you. So I did actually learn to program. So a couple years later, I was at college taking a physics class, and I know how to do classes, so you know I was doing well in the class. But the teaching assistant said to me, hey, I need a programmer for a project. Would you be my programmer? And I said, I don't know how to program. And he said, yes, I know. That's why I'm asking you, because I have no money to pay you. And if you knew how to program, I'd have to pay you. But you're obviously smart, so I'm sure you could learn. And so I agreed to be his programmer because I knew I had a friend who knew how to program, and I figured that was a safe way in which to learn. My friend would help me, and indeed there was nothing to it. It's all logic and so forth. So then I went to graduate school right after undergraduate. So this was in mathematics at MIT, which is a great place to have on your resume. It's not necessarily the greatest place for an education, but at any rate, the math department especially was very unhelpful, and they didn't help you find an advisor. You had to do that yourself, and I was very shy and insecure. And in fact, my perception of graduate school was that all the other students had gotten in because they were smart. And I'd only gotten in because I studied really hard. And if anybody knew how hard I had to study to get the grades I got, they would realize I was just an ordinary person and not one of these other species that were able to do original research. Now, it turns out everybody feels that way. It's called the Impostor Syndrome, but people don't talk about it enough, I think. So, you know, hopefully it's reassuring to you to know that everybody actually feels that way. After I did all my courses and exams, I had to start on a thesis. So I tried knocking on the doors of professors and saying I needed an advisor, and they would always start out by saying, well, I'm a big, important, busy person, which was very discouraging. Sometimes if I didn't leave their office quickly enough, they'd say, so what are your ideas for a thesis? And it's like, gee, I was hoping an advisor might help me with that. But at any rate, when I didn't have an advisor, I didn't have a thesis topic. Luckily, this didn't last very long before an old friend stopped by and said, are you enjoying grad school? And I said, no, I have no idea how to do a thesis. And he said, oh, come join our group. And that was at a little company. And it happened to be designing network protocols, in particular routing protocols, and I loved it. It's like you have all these little computers doing their own little stuff with what they can see locally, and somehow it fits together like a gorgeous symphony. You know, just the beauty of it. I really love network protocols. Now, how I got exactly the right job at the right time was another just amazingly random event. So there was this workshop that happened every, you know, twice a year or so, and people from different companies came to this workshop. The guy who organized it said at one time, he said, there's this really important, difficult routing problem I want you to all think about. So that was how we closed one of the workshops. And then I thought about it, and I realized, you know, the way I do things is I look at it from different angles, and I knew exactly how to solve it. I got myself on the agenda at the next meeting, and I said, here's how to think about the problem, here's the solution. Nobody asked any questions. And then at the end of the workshop, the organizer again said, remember everybody, there's this important unsolved routing problem that I want you to all think about, which is what I had just presented. So afterwards, this guy from Digital Equipment Corporation who was there came up to me and he said, that was incredible. We've been thinking about that problem for so long. Once you see the solution, it's so obvious. So thank you so much. I said, oh, good. And he said, we'll use it in DECnet. And I said, good. And then he kind of looked at me and he said, are you happy professionally? And I said, I guess so. And he said, well, you were just completely ignored. Didn't that bother you? And I said, oh, everybody always ignores me. I'm used to it. And he said, no, you have to come join Digital Equipment Corporation. We will not ignore you. And that was how I was offered the chance to be the person to design Layer 3, which is the routing protocols at Digital, which was the place to be for innovation. It was, you know, really just very good luck. Yeah, so what's a routing algorithm? So the idea is you plug the network together like Tinker Toys, any way you want, and hopefully you don't have to configure anything. And these little circles, which you can call routers or switches or whatever, let's call them switches, they just figure out, based on what they can see locally, information. They exchange information with their neighbors, and ultimately they can all figure out which direction to forward data to. So yeah, the goal is just plug the network together and the switches will figure out how to move the data. So to give you an idea of what my routing protocol looked like, here's a picture of a network. There's 7 nodes there, and the number between A and B says 6, which means that the cost of the link between A and B is 6. So you just plug the network together, you tell them what the cost of the links are, and each node is responsible for creating what I call a link state packet that says, I am Radia, I have a neighbor George at a cost of 2, a neighbor Bob at a cost of 3. And each one of these nodes generates one of these things and sends it to everybody. So everybody has the same database, which is the link state packet from everybody else. And with that, there's enough information to calculate everything that you need. So that's the basic, very quick summary. So yeah, my general philosophy, when I was designing it at first, I was designing it for people like me, that you just plug it together, you don't have to think about anything. And then people told me, Radia, we have customers that really enjoy configuring things. And I said, really? Well, okay, they want knobs, I'll put in knobs, but you don't have to touch them. And even if you do start playing with the configuration settings, you can't hurt yourself. Any setting will still work. So that's, that's my philosophy. So the stuff I did, you know, is really how stuff works on the internet today. And I also did this other thing, which ironically I'm more known for. It was something that I spent literally 1 week on and thought was a bad idea. It was to bail the industry out of a mistake that they had made. And that's the spanning tree algorithm, and I'll talk about that. And it's just easier to explain in one word. If people say, what did Radia do? Well, the spanning tree algorithm. So let me tell you the story of that, just because it's kind of a funny story. So Ethernet, as first invented, was what's known as a local area network. It was just a way of cheaply hooking together a bunch of machines in the same building. So they would all be attached to the same wire. If anybody spoke, everybody else could hear it. And it could only support a few hundred computers hooked together inside of a fairly small space like a single building. The actual protocol, you may wind up hearing this acronym CSMA-CD. And you can think of it as being a very logical way for a bunch of people sitting in a conference room to behave. CS is carrier sense. That means listen before you talk and don't interrupt somebody. MA is multiple access. That means don't hog all the bandwidth because it's being shared. CD is collision detect, which means that if you're talking and somebody else starts talking, both of you stop because people can't listen if multiple people are talking at the same time. Now, I seem to have been born with CSMA-CD in my brain. I cannot interrupt somebody, and if somebody else starts talking, I will stop. But I'm really amused when I'm in a conference room at how many people don't seem to do this, because you know, you'll have 3 of them talking at the same time, happily ignoring the fact that other people are talking. And some people, when they feel like talking, they just talk. It doesn't matter if anybody else is. But anyway, that was what the original invention of Ethernet was. So people think Ethernet is really successful because every machine that you have has an Ethernet port. But no, Ethernet died very shortly after the spanning tree stuff. And it has nothing to do with this thing that was invented. It's just sort of the same name. So people got confused when Ethernet appeared on the scene with great fanfare, and they assumed it was the new way of doing networking. So they were building their application on top of Ethernet without my layer, which was sort of equivalent to IP. My layer is the thing that forwards information across different links. Ethernet was just a single link. So I tried to argue with them, and I said, no, you still need layer 3. And they said, oh, go away, Radia. You're just upset that nobody needs your layer anymore. And I said, but you may want to talk from one Ethernet to another. And they said, our customers would never want to do that. So they were very successful because their application was a good application. They would have been just as successful had they done it correctly with layer 3. But you know, it's hard to explain to management that. So my manager years later said, Radia, we need to design a magic box that will sit between 2 Ethernets and let somebody over on one talk to somebody on the other side, which is what my thing was all about. Hello. But the constraint was that to use my thing, the end nodes had to cooperate. They had to put it in the right kind of envelope and so forth. So the constraint was figure out how to build a magic box that works with end nodes that just think they're speaking on a single Ethernet CSMA-CD link. So the basic concept was that this magic box, which we called a bridge, listens to every single message it sees on each of its ports. That's called listening promiscuously. Stores it up, and then when the ether is free on the other ports, it forwards it on. And then an extra enhancement is you can, when you receive a packet on this port, you look to see the source address and say, oh, okay, if I got a packet with source address A on this port, A must be over there. And then if J were to send a packet to A, then it knows it doesn't need to forward it. Or if A were to send a packet to C, it knows it only needs to forward it there. But if A sent a packet to J, since it doesn't know where J is, it would have to forward it onto both ports. So that was the basic concept. But it, but it only works if there's no loops. There has to be only one way to get to a particular source. And with what I just said, if there were loops, it would just go around forever. So that was why the spanning tree algorithm, where the bridges talk amongst themselves and figure out which ports are redundant so that you don't forward data on those. So here's the physical topology where the green lines, well, the blue lines, I guess, are Ethernets. The black lines are ports. And these are dotted because the spanning tree algorithm said we don't forward things on those ports because you'll have a loop. And so this will wind up with Spanning means it reaches all the links, and you know, and there won't be any loops. So that's what the spanning tree algorithm does. So the story behind it is kind of funny, which is that my manager asked me to do this late on a Friday. And he thought it was going to be really hard, too. He said, oh, just to make it even more challenging, make it scale as a constant. So the amount of memory necessary to run this in one of the bridges should be a constant no matter how many bridges and links there are in the world. And that's a crazy thing to ask. Nothing acts that way. So that night, and he was going to be on vacation the whole next week. And this was before you could, you know, people read email while they were on vacation or had cell phones or electricity or indoor plumbing. This was a long time ago, 1980s. So that night I realized, oh my goodness, it's trivial. And furthermore, it scales as a constant. The way it works basically is that if you're a bridge and you have, let's say, 6 ports, you have to remember the best spanning tree message you've heard on each of your ports. So when you're receiving messages on this port, you say, is it a spanning tree message? And if it is, you compare it against the one you have stored, and there's a trivial comparison to decide which one is better, and you store that one and throw away the other one. A spanning tree message is about 50 bytes, so if you have 6 ports, it takes 300 bytes to run it, no matter how big the world is. So I was all excited. So Friday night, I knew exactly how to do it. I could prove it worked. Monday and Tuesday, I wrote the specification in enough detail that the implementers got it working in just a couple of months without asking me a single question. But then I had the whole remainder of the week where I was too excited and I had to show off to my manager who was still on vacation. So I spent the remainder of the week working on the poem that goes along with the algorithm. And it's the abstract of the paper in which I published this. And so the poem is called Algorhyme, because every algorithm should have an algorhyme. So the poem is, I think that I shall never see a graph more lovely than a tree whose crucial property is loop-free connectivity, a tree which must be sure to span so packets can reach every LAN. First, the root must be selected. By ID, it is elected. Least cost paths from root are traced. In the tree, these paths are placed. A mesh is made by folks like me, then bridges find a spanning tree. I think you should always have fun with anything that you're doing. So then I went back to graduate school the second time for bizarre reasons, and this was 10 years after I had dropped out. It was so much easier the second time because I had self-confidence. I was afraid, gee, I would have forgotten everything I had known, and indeed I had. But also, I decided to go in computer science because I'd never taken any computer science classes. So I was really kind of starting fresh, but I knew some secrets. Like when you get a problem set, start on it as soon as you receive it rather than waiting until the night before. And when the professor is making no sense, ask a question. It never occurred to me before. I always assumed everyone else is following, and I would waste the class's time if I asked a question. But by then I'd taught several times and stuff, so I could tell when the whole class was lost. And sometimes I even knew what he was saying. I would still ask a question just to make him clarify something that I knew other people weren't following. And also I used to, my first time in school, whenever I had a test, I would, in a panic, leaf through at all the problems, and it would take me like 15 minutes to settle down to actually start working them out. In the second time, since I taught, I actually was looking forward to seeing what kind of test problems the professor would come up with, because it's actually very difficult to come up with good ones. And the first time I thought the professor was trying to trick you by asking hard problems. The second time I realized, no, if you've been doing the homework and you understand the class, you'll do just fine on the test. So it just was amazingly much more wonderful experience, and I wish I'd had the same attitude the first time. And by the way, it's much easier to go to grad school with kids than working. So when I was in grad school the second time, my kids were young. My daughter was about 7, and there was this great story. She was so proud of me, and this is a story that could not have happened any place but Cambridge, Massachusetts. So she was in a playground in Cambridge, and she met this other little girl. And so she said to the other little girl, "My mommy's going to get a PhD from MIT." And the other little girl said, "My mommy already has one." Which was true. She had a PhD in chemistry. We got to be great friends. And then what really changed my life, nothing I did before really mattered, because I wasn't very good about saying, me, I did that, or acting like the way people perceive really smart people act. You know, I'm sort of very down to earth, whatever, very approachable, which I like, but people would have trouble seeing me as an authority on anything because I just seemed so normal. Until I wrote the book, Interconnections, which is about layers 2 and 3 of networking. It became the book that everybody learned the field from. And it was just so cool. You get so proud of books. It was very educational writing it. And so then, like, if you go into somebody's office and you see your book on the shelf, it is so thrilling until I got spoiled. And then I'd walk into people's offices and see networking books, and if mine wasn't there, I'd be crushed. So one time, I went into somebody's office where he had a bunch of books, networking books. Mine wasn't there. And so I pretended to be cheerful, and I said, "Hey, where's my book?" And he said, "It's at home. I'm in the middle of reading it." It's like, oh, okay, that's good. But the funniest story was once I was in Chicago airport. I had 4 hours between planes, and I was so tired, I couldn't do anything useful. The airport was pretty much deserted for some reason, very few people around, and I was just walking around with my 2 carry-on bags, kind of in a daze, and I saw this group of about 6 men sitting and talking, and I thought I overheard some of their words. I thought I might have heard router, I thought I might have heard bridge. There was a book on one of their laps that I could just see the edges of because he had papers on top, and it was the right color to be my book, but you know, it's just white, you know. So I took my awkward carry-on bags in this empty airport and maneuvered myself to sit right next to them, at which point they stopped talking and they stared at me, and I realized, oh, I'm acting bizarre. How embarrassing. So I said to them, "Oh, I'm sorry, I was just curious. What is that book?" So we pulled it out, and it was my book. I said, "Oh, I'm Radia Perlman." So they all turned completely white. And when one of them could recover enough to actually talk, he said, "We are in a panic trying to prepare a presentation for customers, and we're trying to figure out how to pretend we know what we're talking about. And right before you showed up, one of us said, 'If only the author of that book were here.'" And I said, "It's not a problem. You buy the book, you wish for me, I appear." You know, so I said, "How can I help?" And so I helped them with the presentation, signed their book, and I never had more fun in an airport. So just some sort of observations at life. In school, you get into kind of a bad habit because all of your work must be your own. So everybody in class is solving the same problem, but you must do it independently. When you go to work, it's very much not that case. The problem is to solve the problem. And if you get help, that's great. You know, it shows teamwork and all that. So, you know, that's an important distinction that you have to realize. It's bad if you go in and you're always saying, me, I did that all myself, but look what we accomplished. And if you ask people for help, they in general love to do it They're honored that you ask them, and likewise, you should be honored when other people ask you for help. Another thing is a lot of what everybody knows is not actually true. There's all these buzzwords that don't mean anything, and they traumatize engineers. Buzzwords are great to use on customers, but when you're talking to engineers, about 80% of engineers think, oh, everyone else knows what that means, but I don't. And so examples of buzzwords that I run into, are like third platform. I don't know if you've heard these buzzwords, or software-defined networking. Or SDN. All of a sudden, all the networking conferences would start with a keynote saying what a privilege it is to be born at this point in history when SDN is transforming the planet. So I've been asking people, what do you think it means? And I've separated it into about 7 completely orthogonal technologies, none of which are new. So when you talk to an engineer, don't say, do you think we should use SDN technology? Be much more specific about what it is. So, aside from the buzzwords that are just confusing, there's also a lot of statements that people make that just are not at all sensible. So real breakthroughs come from questioning assumptions. So when you hear something a million times, don't say it must be true because I heard it so often. Think about it and say, gee, why would that really be true? And sometimes it's not. So parting thoughts, think critically, ask for and give help, be generous with credit. You will gain way more by being over-generous with credit than you would gain by having people think that you did most of it yourself. Nobody knows everything, and be a true leader and good role model by admitting that you don't. And it's okay not to be the best at everything, and it's okay not even to be the best at anything. Be a part of a team. But in my book, I have these little things I call real-world protocols to illustrate the point that I'm trying to make. And they're just sort of funny. I mean, my books are actually funny, even though they're kind of serious textbooks. So like an example of scalability, I talk about the wine glass clicking protocol, where it really doesn't work very well with more than 6 people if everybody has to click with everybody else. It seems like there could be a better protocol for making sure everybody gets clicked. The one that everybody loves is an absolutely true story. And the point I'm making is you should know what problem you're solving before you try to solve it. And in this industry, it's actually a real problem. You try to say, well, okay, we have this problem. Engineers get so excited, they start writing code already for the 2 special cases they can think of. Turns out, no, it doesn't work in all these other cases. They have to add more code for that. They wind up with this huge monstrosity, whereas if they just took some time first to really understand the problem, you would be, come up with a much simpler, more general thing. So this anecdote, which as I said is completely true, will forever cement in your mind why you should know what problem you're solving before you start to solve it. Which is that my son, when he was 3, ran up to me crying, holding up his hand, saying, my hand, my hand. So I took it and I kissed it a few times. What's the matter, honey? Did you hurt it? And he said, no, I got pee on it. So, thank you, that's the talk. Okay, so people can ask questions. Feel free to ask questions about anything. If I don't want to answer, I won't answer, but you really feel free to ask anything. So, yes, Okay, so the theory is I'm supposed to throw this to you. And I should tell you how much our family was into sports, which is that when my kids were like 12 or something, we were talking to a family in a different town, and the family was saying their school had so little money, they were thinking of getting rid of physical education. And so one of my kids very sincerely said, "Can we move there?" So at any rate, who raised their hand? Okay. Oh, it's better than I expected.
A personal question, if you really got married to that intelligent mathematician guy you were looking forward to?
Oh, I didn't understand the question. Say it again.
That if you got married to
yes, I'll tell the
mathematical guy.
Yes. Yeah.
Well, that was my question. I just wanted to make sure that you look that, seems to me that you are happy in what you do, but in the personal matter, if you are happy as well.
Yes. No, I have this fantastic relationship. And I also learned that you couldn't line people up and say this person is smarter than that person. There are so many different skills, and some of them, like the fact that I can't remember anything. I can only remember like 3 things, so if you ask me to memorize something else, I'll have to forget something important like my own name or something. So people are good at different things, and I think the reason I'm so good at what I do is that I couldn't remember all of these details, and I had to extract the thing down to its very essence. But as for relationships, as a protocol person, I'm always sort of watching how people interact as well. I see so many couples where they're always criticizing each other. You know, you work too hard, you're too fat, you should pay more attention to me. And once you get into that mode, it's all downhill. I don't know if you can ever recover from that. I mean, we've been together for longer than a lot of you have been alive, and 24 hours a day is not long enough to be together. And when he comes home from work and I'm at home, he said, it feels like he has a large puppy because I'm so happy to see him. So basically my advice is, for a relationship, your job is to make the other person feel self-confident and happy and safe and smart and empowered and all that. So, I say assume that your partner has no memory, and even if you've told him or her 20 minutes ago that they're the sexiest, smartest, sweetest, funniest person on the planet, do it again. And, right. And if you have 2 people that really want to make each other happy, then, that's what I think it's all about.
Hi, over here.
Okay.
I'm a Cisco Academy student, and I'm a big fan of your work. And now that I know you, I'm more of a fan. And I like how you talked about not fitting in, because I'm doing good in school and stuff, but sometimes I feel like I don't fit in with my other classmates, and sometimes I feel like I've lost the passion for my work. How do you overcome that? How did you, I don't know, like, get the passion to do your work or make network protocols?
Yes, okay. Well, if I want to be honest with you, it's not all sunlight. There are some times, where there's ugly politics, and I spend many nights at home crying instead of sleeping. You will have hard times. I do happen to love network protocols. They're just so incredibly fascinating. But much more important to me than what I'm doing is that I'm working with colleagues that I like as people, and I respect as people, and I can learn from them, and so forth. So I've always taken jobs not due to any sort of logical reason of this is the right place for me to be. I actually look at the people and decide whether I really want to spend a lot of time with them. Now that I'm sort of old and cranky enough that I can feel empowered to try to change things, I'm actually at my company trying to make a big deal out of corporate culture and figuring out ways to make people from different groups talk to each other, because it's so important for cross-fertilization, make it easy to learn things. Most of the talks you couldn't possibly understand unless you were in that group, not because it's technically deep, but because it's just full of acronyms and so forth. One of the saddest things that I see is I look at the company cafeteria and I see engineers buying lunch, looking around, and there's nobody there that they know, so they scurry off to their office and they eat it all by themselves. What a missed opportunity. So, I would like to change the industry, that way, to make everybody, all the companies, kind of be more aware of this thing, and don't reward the people who are acting like bullies. And if you feel sort of different than those around you, I'm different from those around me, and that's what makes me valuable. I look at things a different way. So, yeah. So there's questions all the way back there, but there's no, he seemed the most enthusiastic, the one with his, could you stand up for a second and maybe somebody can get the mic to you? Okay, he'll ask first and then you can. Okay.
Perfect. Well, at first, I've been very honored to be in front of an icon in networks like you. So thanks for coming to Campus Party. I think that we are all gratitude with this talk. My question is that you, as an expert, as a creator of protocols, what are your predictions, or what did you expect in networking? Well, sorry, in networks in the future. What did you expect? What did you predict? What, as an expert, what you can tell us?
Right. So, what do I predict as the future of the internet? Boy, if you'd asked me what the internet was going to look like 20 years ago, I would not have had a clue. And there's a bunch of things there that cannot possibly work, but they do, like Wikipedia. The fact that anybody can edit that, it ought to be just full of rants about Obamacare or whatever, but it's a great source of well-written, accurate information. It's astonishing. And we're getting to be more and more dependent on it, which is extremely scary, because when it's down, you can't, the airlines can't check people in, all this kinds of stuff. And there's so much money to be made by being disruptive, distributed denial of service. So these are things I'm all interested in from a technical point of view. Like this, I'm also interested in security things. But where it's going, I don't know. You kids these days do all this weird stuff like Twitter. So I actually, it turns out like 10 years ago, I went to a class on Twitter. And apparently, I created a Twitter account. I'd forgotten that I'd done this, and sent out one tweet. And recently, I gave a keynote at something, and somebody checked to see if I was on Twitter. And so he found my one tweet, and he thought it was hilarious, and he posted it. My one tweet was that I said at this class was, I can't say that my life was any less complete before this class. So that was the one tweet I've ever given. So yeah, I really, oh yeah, my daughter was kind of appalled at me. Then my kids are all grown up. She said, you're in computers, you're in networking, you have to have a Facebook account. So she created two Facebook accounts for me. One was a private one, one was a public figure one, I guess. And yeah, I never log in. I get all these friend requests, and I feel really stupid for being like I'm unfriendly if I say no, but I'm never planning on really posting. So yeah, I'm not really sure where the internet is going. I think that's kind of for you young people to define. What I did was kind of the boring underlying stuff that hopefully nobody actually sees, but the actual uses of the internet, incredibly exciting, and who knows where it will lead. Yeah. So where was the person with the hat who oh yeah, let him ask. All the way in the back there.
Hi, thanks. Well, first of all, thanks for your time while we get this conference. My question is kind of similar to my friend here. As an expert, from 5 to 10 years from now, how do you see networking as a student? I want to know which path to take. I mean, I just finished a CCNA, Cisco CCNA, but I don't know the path. What do you think is going to get the bigger grow in order to know which path to take? I mean, from data centers to voice IP to, I don't know, maybe you as an expert, maybe you can tell me.
Right, sometimes it feels like, gee, everything's already been done, you know, so how can I contribute to the world? But I think it's an incredibly exciting time to be young and energetic these days, because just applications that you can write that use the internet, but kind of the more, I mean, I think kind of research areas that people haven't thought about much is, and they should think about more, it happens to be what my thesis was about, which is how you make a distributed algorithm work when some of the participants are malicious. So in my thesis, I said how you could design a network that even if some of the switches were giving wrong information in the routing protocol, or flooding the network with garbage, or forwarding in the wrong direction, or doing everything perfectly but throwing away packets from you, how can you make a network resilient to that? And again, it was like really straightforward and reasonably practical. But there are so many different areas. There are so many technologies out there where people say, I'm going to have 7 copies of this thing, so it'll be really resilient. But what I see is 7 single points of failures, because each one of the copies, if it were to immediately die, the other 6 can take over. But if one of them decided to misbehave, it can easily tell all the other ones, you know, throw away all your data, or modify it in this sort of way. And so, you know, that's something, again, that is a whole area that I think would be good. The other thing is usability. You know, I like to say, gee, you'd be expecting to be able to have a graph of usability versus security, that the more usable it is, the less secure, and vice versa. The industry has managed to find the spot on the curve, which is minimally usable and minimally secure. So just making, oh, right, I have a quote that I wrote, you know, from my security book that I wish people would really understand. It's funny, but it's also important. So the quote, if I can remember it, is, humans are incapable of securely storing high-quality cryptographic keys, and they have unacceptable speed and accuracy when they're performing cryptographic operations. They're also large, expensive to maintain, difficult to manage, and they pollute the environment. It's astonishing that these devices continue to be manufactured and deployed, but they're sufficiently pervasive that we must design our protocols around their limitations. So what I'm saying there is, don't expect people to have to learn to use your thing. You know, I hate it when I hear people say we need more user training. It's the user's fault. They clicked on that link. Or you tell users absurd things like, Don't click on suspicious links. What's a link? What's suspicious? Yeah, if you could design things that are completely failure-proof and intuitive for people to use, that would, that's another great area.
Thank you.
Oh, just one more question, I guess we're... So there's plenty of questions. Just give it to somebody.
Hi. Sorry for the other guys that wanted to ask a question.
Oh.
Well, I consider myself to be very passionate about studying and trying to be the best I can be regarding school and getting good grades, and my cell phone's ringing. There, done. And sometimes when you're in school and you get assignments in which you have to cooperate with your teammates, and sometimes they don't have the drill that you have. They slack, they try to give the most time to the assignment, and they start doing it 2 days before it's due. Sometimes they just don't put the work it's needed, don't put the attention, or decide to go into other subjects. So how do you deal with that? How do you deal with the pressure of you having to do everything?
Yes, that's a great question. And I run into that a lot because I'm a series editor for my publisher, which means I mentor authors through the process. And almost always, when there's multiple authors for the same book, they call me up and say, I'm going to kill him. And nobody's killed anybody yet, but a lot of books don't get written. There's always the perception by one of the authors that nobody else is doing their job, and it's very difficult. I tend to, like when I'm doing patents, I put a whole bunch of people's names on it because they were just in the room, or because I asked them one question of what does this acronym mean. And I don't mind that I'm doing all of the work. It kind of bonds them to me that I've thought to include them in something. So yeah, I mean, the only advice I can give is don't resent it too much. Try not to work with those people again. You might actually try to find out why it is they're not doing it. But there's a lot of people that like to latch onto projects in order to get credit for it, but they don't actually want to do anything. So that's not at all uncommon, and it's unfortunate, but do the best you can and try not to let it eat you up with resentment. Yeah. So I think they're closing it down now. I think they have a little area that we can stay around and just talk for a while. People that want to continue talking can. And later on in the day, I have some interviews or something. And then after that, I'm happy to kind of sit in a room and talk with people if they want. Someone here will know where I am. I have no idea where I will be, when I will be, but someone else will know. So thank you so much.